All right, welcome guys. Happy Thursday. Right? It's not really Thursday, it's Baby Friday. You know what I mean? When Baby Friday grows up, it becomes Friday. Ever heard that? All right. So, so we're gonna have a bit of fun today. We're gonna kind of head off the beaten track a wee bit, and we're going to talk about images today. So we've been dealing with images a little bit in the sense of we've seen how to kind of bolt on an image element, but we haven't really talked about what different image file formats we have available to us, why they're different, and how to create them, how to embed them in a page. So we're going to look at two types of, well, a number of different types of image formats, but two general classifications. One is bitmap, and the other one is vector. And what are the differences, and why do you need to appreciate that, particularly as you build lightweight, network-ready applications, right? Because the images a lot of times can be the things that will slow things down in terms of your bandwidth. So I've got a few goodies for you to download. And today we're gonna take a break from working with a server, so we'll do most of our work locally today. So that's fine. So log into Blackboard, and there's some goodies I'll have you pull down to your local desktop here. And so today's lesson is under learning modules. We're on to module 5, images. Okay, so let's download, if you could. Download, if you could, image files, lesson 5 files.zip. Save those down to your local machine, your documents folder, wherever you store your files for this course. Extract all of the files immediately. You can get rid of the underscore Mac OS 10 folder. If you're on a Mac, you may not see it. You just need the folder called lesson files, and in there you can also get rid of the .ds-store file. We don't need that. You should have an image folder, an index page, and a picture.html as well. So that's great. Let's open up our code editor. Actually, before we do that, while we're working in the background, we're going to download a piece of software. If you have not, it's called GIMP. So dial up GIMP into your search engine, and the first hit should be GIMP, the GNU Image Manipulation Program, GIMP.org. So while we're working, it's a rather big download. While we're working on some of the code to support these images, we're going to pull this down. Some of you may already have it. GIMP is kind of like an open source. It's a safe program to download, so don't worry about it being bundled with any kind of malware or spyware or adware or anything like that. It's kind of like an open source version of Photoshop. So if you are hesitant to spend the $400, $500 on Photoshop, you can certainly pull down the GIMP program. So I would pull it down directly. Depending on our network here. And you can run the exe. And let that rip. So while that's crunching away, let's pull up a code editor. I'm going to, you know what we'll do today? We'll use, yeah, we'll just, I want to use Visual Studio Code. VS. Okay, so I'll pull up Visual Studio Code. You can pull up whatever code editor you want. So let's open up, go to File, Open Folder, or Open Project Folder in Atom, or whatever you want. We'll head down to, where did I stash it? Lesson Files. Lesson Files, that's the one I want. Very cool. So we should fire up index.html. Oops. There we go. There's our word wrap on. Cool. All right, so now we've got the index page up and running in our code editor. Let's pull this up in a browser. So head over to a browser, open a new tab, Control O for open, or Command O, and open up the index page. Make sure it's the same page in the lesson files, index.html. So open that up as such. So we should see a pretty plain and ordinary page. It's got a blue background, a number of different, a primary heading, a number of different subheadings, with some links. So here's what our code looks like. So, and we're going to get into different ways to apply these visual styles. we've got a class on hyperlinks, which I'll deal with, and then we're going to get into CSS. So this is a piece, the style element here inside the head section. Here, this is actually a different language. So this here should not look familiar to you. That's CSS. It's called embedded CSS. So the style tags are HTML, but not the content between them. So the embedded CSS belongs in the head section. So the head, we have the language attribute, that's cool. Our character encoding, that's cool. Useful title. And then we close the head section, open up the body. And then we have our header with our primary heading. And then we have our main section of the page, the footer of the page. And inside the main, I have 1, 2, 3, 4 sections, 4, 5, 6 sections. And it's a good idea with a section to add a heading. Like if you're going to add a new section to a piece of content, you know, what is a section for? Add some sort of heading. Usually it's a subhead, an H2, and that's cool. So I've got a section here for each of the different kind of primary image types. So the first type of image that I want you to look at here is the Joint Photographics Experts Group, or the JPEG format. So let's embed one here. So we go into 21, line 21. No tab for me. Oh, there it is. Tab's working now. We'll use the image element, IMG. No tricks there. We add a source, src, equal to. And inside the source attribute, you can add a relative or an absolute path. So you can say http whateversite.com/images/whatever, or you can point relatively from the piece of HTML that is calling up this media. So we're embedding the media. Let's take a look at our folder. In lesson files, in the image directory, IMG, we're looking for a folder called tree-sunset.png. Okay, so from here, if we look at the files, I have to go up. I have to go into the image directory and grab tree.sunset. So that's what I want here. So the relative path is img/tree-sunset.jp, and watch the extension. A JPEG can sometimes be JPG or sometimes be JPEG. So be very careful. That's a big gotcha. Both of those are considered to be valid file extensions for the type JPEG. Either one. And the image element is an empty element as such, and so you can close it like that. So inject that in there. Save the page, and reload the page in the browser. You should get the picture of the sunset. Okay. That's not right. It's actually wrong. Okay. Just because the picture renders on the screen doesn't mean you've done it right. Okay. You've got part of it means you've got the image path right, But we haven't done a number of things that are really important to do with embedded media like images. First thing is we have to provide an alternate text version of this image. And that is because a lot of times people will have images turned off, or they may be reading the page, they may be accessing the page in a non-visual way, maybe with a screen reader. Or the image may fail to download because you're in a bandwidth constricted environment. Who knows? So you want to tell the visitor, what is this image? Should they not be able to see it, what is it? So we use the alt, which means alternate text version. And we'll call this tree at sunset by Chris Sorge. Sorge. or you might even be more specific, photo of tree. So it doesn't have to be a long description there, but it should. If you close your eyes, you can imagine trying to describe the picture to someone who's got their eyes closed. That's the best way to describe what you put in an alt, right? Search engines are looking for that content in there. They're looking for keyword phrases. So that's part of your search engine optimization, is making sure you have well-crafted alt attributes that make sense to human beings. So design it for a human being, and you'll be rewarded by the search engines. Don't design it to fool the search engines and expect to be rewarded by human beings, right? That's called spam. So that's cool. That's great. So we save that, reload the page, and that should do nothing. It's fine. So that works in images off. You can go up into your settings for your browser. This one, they're always moving these around. If you go into the kind of the vertical ellipsis up here and go into the settings, and we'll see if we can figure out how to. You got to really dig deep to turn off the images. It's not. Maybe go into the advanced settings. Where do they stash it now? You might not be able to find it. Turning off images.
It's in content settings. Do not show any images.
Content settings. All right. Web content.
Yeah, content settings, privacy.
Under privacy. Oh, content settings. There you go. Show all images. So you can deselect. You can set do not show images. And we'll see if this version of this browser on this particular operating system, what it does. So we said done, and then we can close this setting. We'll leave the settings tab open. Now refresh the page. Okay, so there is there's the alt. So this is what happens if the image fails to download or the images are turned off. At least you're giving the person an idea about what they're missing out on, for lack of, I guess, really. But also, again, helpful for things like for search engine optimization. It does help. So every little bit helps. So we'll turn those back. We'll go back and turn that back on. Wow, that's in privacy settings. I don't know. You can do that with just about every browser. You'll have to dig into the settings. They don't make it easy to turn off because they don't want to generate tech support calls or support emails. And reload the page, and you should get the image back. So alt. If you don't have an alt attribute on your image, your page will fail validation. So if you pass it to the validation service and you've got image elements without alts, those are errors. Like those are markup errors. You will fail validation. That has to be there. So we talk about organizations. You'll hear of things like AODA and accessibility requirements and legislation. This is the really, really basic stuff. Like if this isn't there, forget about the advanced stuff. You have to have at least alt attributes on your images. That's the easy stuff. Cool. So that's fine. We still haven't done a really good job of this. So let's go look into our file system and take a look at this image here. And you can do this in a number of ways. Every operating system handles the metadata for JPEG files or media like that a little differently. So if you click on this, you can see I get a little bit of metadata here. If I right-click on it and I get properties, you should get a little bit more in the way of what we call metadata. So the JPEG image will give you the file size, right? So it's 25.7 kilobytes. Based on the disk allocation space, so it's 28. There's a default application. Every operating system will have a default application that handles that MIME type, which is type JPEG. You can go into the Details tab here. And they may be, the JPEGs may embed other metadata like the author, the date taken, the photograph, whatever program name was used to modify the image, any copyright data, so the JPEGs can be embedded with copyright information. So if you're using a JPEG, if you're swiping a picture off the web and jamming it on your page, yeah, you could find yourself in court because the image you just jammed on there is just broadcasting, hey, I stole this. It's not mine, and it's easy to find you. So make sure that when you're using an image, you have the rights to use it. You either paid for the rights to use it, or you took you've asked permissions, or it's what we call a Creative Commons. So the usage rights are you're allowed to use it in a commercial or a non-commercial capacity, right? Or you took it yourself. It's your own picture. Those are the ways. So swiping stuff on the web and posting it and serving it up as if it were your own is actually it's against the law, right? It's a violation of copyright law. So you have to be mindful of that. Other metadata might include the dimensions of the image. So this is the native resolution. So this is how many dots are used to actually make this bitmap. A JPEG is a bitmap, it's a series of dots that are comprised, built for this page, which will make this image. It's not a series of drawings. They're dots. The resolution. So this means 96 dots per inch. So that means if it's rendered at full resolution, you'll get 96 of those pixels in an inch on your device, on your screen, right? We'll kind of break that. Bit depth, 24-bit. That's how many colors are used to render the image, and JPEGs can use millions of colors in the color palette to generate the image. Sometimes there's camera information stored in a JPEG. That may or may not be present. Things like the shutter speed, the aperture, the make of camera, these kind of things, right? So that can be focal length, ISO speed, which is like the film speed, which is now at CCD. It's not really a film anymore. Well, it can be. The original can be on a film. So on so forth. You can see there's all kinds of metadata that can be embedded, even though the image itself is actually is binary. So we'll go and take a look at this. So go to your code editor just for fun, and go to File, Open, and we'll try and open this image, the tree at sunset, in your code editor. And it just shows the picture. It doesn't show the code. The code it's actually binary, right? It's not text. It's not a text-based medium. Cool. So, but what we're supposed to do when the browser downloads the page, the HTML pulls in, and then sometimes there's a bit of a lag as it recognizes, oh, this is another piece of media. So it starts to download that in parallel, maybe with other resources on the page like JavaScript libraries, CSS. There may be other, audio or video streaming into the page. So the HTML page may render before this actually comes in. Okay? So one of the things that is considered good practice to do is before this comes in, the page, the rendering engine doesn't know how much space to allocate for the picture. It doesn't know the physical dimensions of the image, even though that may, if it's embedded in the metadata, that image hasn't downloaded yet. So what happens is, before this downloads, you actually get, like this text up here is placed right up here. It doesn't leave any space, and then when it comes in, the page kind of rearranges itself, right? So in order to avoid that re-rendering of the page, at the outset, we should tell the browser, the user agent, how big this thing is. So how we figure that out is we go into, of course, our properties. You click on you can either go to the properties, or sometimes there may be, so general here, no, general won't give it to you. Well, security? No. So you go into the details. It will give you the native dimensions of the image. So it's wide, 500 wide by 375 high. So what we do is we go into here and into the image after the alt, and we say width equal 500 and height equal, was it 375? Okay, we don't provide any units of measure like pixels, just a number. So that's really, really important. It's not necessary, so if you don't include width and height on the image attribute, your page will still validate. You're good to go, right? If you do though, the page it won't jump around and won't re-render itself once the image comes in. So it provides a bit of a smoother user experience. So it's considered good practice. And let's take a look and see if we can hit the inspect button. And if I go to network, so what we can do is we can actually simulate this coming down. DSL preset. Let me see. Let's simulate a 2G connection. That's right. So I reload the page. You can see that there's it tracks the time for this stuff to come in. I wonder if can I slow this down any at all? 50 kilobits per second. Let's try that. I can see it took a little bit longer. So what we can see is we can see how there is a bit of lag for these things coming in. As we add more elements to the page, you can see how the page performs in a low bandwidth situation. Say, wow, nah, I've got high speed at home. Sure you do, or maybe you don't, right? But the reality is, in a lot of places, people don't enjoy very good bandwidth, high bandwidth connections. So we got to consider that. So that's cool. You can. I'll show you what this looks like. If I were to change this native resolution, you can resize an image. So I can say, okay, let's change this to, let's double this, so 1,000. And what's 2 times 375? 750? Double that. So save that up. And you can double the size past the native resolution. That's fine. You can do more than that. Let's double this again. Let's go to 2,000. And let's change this to 1,500. Maintain the aspect ratio. But as you do that, you realize that you're losing image fidelity. Right? What's happening is the browser has to invent pixels because they're just not there, right? And now we can see some of the lower quality aspects of the image. So the way the JPEG image works is the idea with an image like this is we need to balance image quality with file size, right? I mean, we can capture a full-size JPEG right out of our camera and slam it on the page and it looks beautiful. That's great. But then this picture is like, 4 megabytes. That's not cool on a 2G connection. It's not cool on a 3G connection, right? So you have to balance that. Well, I want it to look really good, but I want it to download quickly. It's one of these things, right? borrow from one and take from the other, and so on and so forth. Find that kind of. So how the JPEG algorithm works, how it saves on file size, is it's called a lossy compression algorithm. So what it does is it takes this, it says, that's cool, we'll preserve all the colors in the color table. So I'll preserve all the color information for the most part, because a photograph is often consists of a whole pile of very subtle color changes, right? So to say that this picture has orange and pink and purple is to maybe not do it justice, right? There are a lot of colors involved in this gradient in the sky. So we need to preserve those colors. So it preserves the color depth. But what it does do is it discards some of that image sharpness, or that what we call fidelity. So it's a lossy format in the sense that some of that sharpness is lost. Some of that detail is lost when we compress it. And that's why you see this kind of blurriness. It's called artifacting. So you can even, maybe we can zoom it in more. I'll zoom this up really high, and maybe you can see you can find a really good spot on the image here to showcase what this looks like. Maybe you can, I don't know if you can make it out, but can you see squares here? You kind of have to maybe blur your eyes. Maybe look at your screen and just kind of zoom it in. Like hit the Control+ button. I don't know if you can see it. You can maybe make out some squares here. They're very subtle. So how the algorithm works is it takes large areas and says, this area here is kind of like, let's get rid of all those little pixel detail. I'll just make one big block with a gradient. It sort of goes from light purple to a slightly darker purple here on an angle like this, and done. So it throws away a lot of detail, right? And just averages it out in these big blocks. And so as such, if you take that approach, you can imagine that when we get into areas of high detail, that doesn't work very well, because a large area here, a square like this, we have a dark colored branch and some sky behind that. It's not going to be able to average that out into a smooth gradient. So it breaks it down into smaller squares and tries to do that. And it kind of looks like the dog chewed on it, right? You get artifacting is what it's called. So and you can control that when you save a JPEG. You can add more or less to that compression. So you can add an argument to that algorithm, which is like in a percentage, basically. It says how aggressive are we going to discard this information, this lossiness of the file. So the more aggressive you are, the lousier it looks, but the smaller the file size. The less aggressive, the sharper the image looks, but the larger the file size, right? So this one isn't too bad. If you go to Control-0, you go back to the default zoom in the browser. And even as such, if you go to the default zoom, you can see some of those squares, right? It's not that hard to make out. So the compression it's fairly aggressive on this image, but I've also zoomed this up past its native resolution, right? The native resolution was 96 dots per inch. I've zoomed this up, so the browser had to actually interpolate or make up some data to make this a bigger picture on the screen, right? It had to resample it itself. Browsers are pretty good at that now. They used to be terrible, but they're not bad. So at the end of the day, you should put in the native resolution. Now you can do this, and you have to be careful about this. You can change the aspect ratio of the picture. And sometimes you'll see this on a website and go, oh, something looks broken, right? It's just because someone was careless, right? When you're resizing an image, take care to maintain the proportions of the height and width as it was originally captured, particularly in a photographic sense, or it'll look amateur and weird. Something went wrong. Okay. JPEG, that's cool. So this one here, I borrowed from Chris Sorhay from Flickr.com, and I'll show you. You can go to the settings here. So here's this. What you can do and most of them like this, you can go into. We go into a search. Where's our search? Tree at. So you see up here on Flickr, you can say any license. What you can do is you can search these just because they're on Flickr at full resolution doesn't mean you have the rights to use them, right? You need to make sure that you're allowed to use it commercially, non-commercially, or in a government capacity, and can you modify it? Right? Just because you pulled down an image doesn't mean you can go into Photoshop or GIMP and change it and then put it up there. You may not be permitted to use that. This is intellectual creative property. So you have to make sure that the commercial use and modifications may be allowed if you're going to change an image. So you have to be careful. So if I change that, you'll see the number of images that are available now change, right? So and usually, so there are some rights reserved, and very often these rights may include attribution. So it means if you use the image, that's fine. You may not have to pay anybody for it, but you have to credit the photographer with the image. Like I've done here in this code, I've credited the author or the photographer with, and even offered a link back to his profile page on Flickr. Right? So it's important. You can use work that isn't your own on the web, but you have to follow the rules. You have to make sure, am I allowed to do it? And what are those, like, do I have to attribute the author? Am I allowed to modify the picture? Do I have to use it exactly as is? Can I use it in a non-commercial capacity? Maybe yes, but maybe not in a commercial capacity. So think about, it's very, very important to respect other people's creative property, right, and intellectual property. So, yeah, and that's a big deal. So you can find yourself in hot water if you don't pay attention to that. JPEG. That is cool. So let's go down. Let's go down to the next format here. Graphics interchange format. GIF. What is GIF? What I use GIF. Right? So graphics interchange format is actually a proprietary image format. It was owned by a company called CompuServe, and the patent for the format actually just expired not too long ago. So meaning it's now kind of public domain, for lack of a better term. So, but it used to be that if you bought a piece of software, or even if you just bought an operating system, like and it comes bundled with something like Windows Paint, when you save as a GIF, Microsoft then had to pay royalties to CompuServe to sell software that could save as GIF. Right? So there wasn't a free and open license to use that format. There was a cost to it, right? Many of these things are. There's a cost to it. They bury it in the cost of your computer when you buy an operating system or you buy software. You do pay for it. You just don't realize that you do. So not everything is free, and not everything should be free. Anyway, so GIF is just that thing. So let's put a GIF in the page. A GIF is the same thing here. We use the image element, right? And the GIF is also, we have to embed it in the page because it's not text. GIF is binary. It's a binary MIME type. It's not like a piece of HTML with numbers and letters that describe the image. It's actually it's binary, ones and zeros ultimately. So the source of this one here, let's take a look. We want to pull in the Chrome icon.gif right here. So we go into the image folder / Chrome-icon.gif. Okay, that's cool. And will this thing, if I click on this here, will it give me the height and width? No. Come on. Okay. So I'll have to go and get the height and width. Go ahead and get that from your file system. 500 by 500. Right?
It's in the bottom right corner now.
Is it down here? Did they report it somewhere?
That bottom right corner.
Oh, they did. Thank you. That's cool. All right, that's convenient. So 500. That's the native dimensions of that image. So, and we go width. And we don't put px in there, just 500. And we put an alt tag. Google Chrome. I use the HTML or the XHTML style ending tags, like that. So there's your image element with the GIF, graphic interchange format. Let's reload the page. And then we should see the logo. Right? Zoom it in, hit Control plus. So, a couple of things about the GIF format. One of them is that it doesn't, how it discards information, so how it makes a smaller file size. This file size is pretty good for a 500 by 500 image. It's only 28.5 kilobytes. That's not bad. So how does the GIF format save on file size, right? It's called a lossless format, meaning it doesn't discard image fidelity or clarity. What it does to save on file size is discard color. So it reduces the color table to I think it's 256 colors. So things like subtle gradients suddenly become more of a difficult situation when you're left with fewer colors, right? So this is called dithering. And dithering is an algorithm whereby it kind of sprinkles these colors. Like, so it may only have 32 colors in the color table to handle this kind of soft red gradient, so it has to kind of sprinkle them and fake the gradient, basically, right? There's different ways, methods of applying dithering. You can do it in kind of more of a regular grid type fashion, more of a randomized pattern. So there's different ways to do it. The other thing that GIF includes, which JPEG does not, is transparency. So you'll notice, I mean, this file, it is a square file. Like it's a rectangle. It's a bitmap. It's a square map of dots. But of course, we can see the background of the page right here. GIF has something called, I guess, binary transparency. Is that the right term? Yeah, it's the pixels can either be 100% transparent or 100% opaque. Right? You can't get what we call alpha transparency. And that's okay. So what happens is as we get to the edge here, where we step off, you get kind of what's called a jagged edge. This is called an aliased edge. So aliasing happens where the computer at the edge of here, where we transition from a solid color to transparent, it has to make a decision at one point: is this pixel transparent or is it not? Right. So it has to kind of, and then you get kind of this kind of jaggedy step edge. Right? It's not smooth because the format GIF does not, it cannot do partially transparent pixels. It just can't do it. It's not built into it. So now the thing that GIF can do, and we'll see this later, is it can animate. So you can have frame by frame. You can have several bitmaps in a row, which kind of change, kind of like the old cartoons, right? Frame by frame animation. So it can do that. A JPEG cannot do animation. Not with the fancy JavaScript and some other trickery, right? But on its own, it can't. So the GIF, it's very good. It's good at things that perhaps don't need to be transparent against some other background. GIF's good at that. It's good at things that are more illustrative or graphical in nature rather than photographic, because if you need lots of subtle colors, it's not very good at that, right? So the only reason you'd use a GIF nowadays, though, is probably if you needed to have some sort of bitmap that was animated, in a sense. So there is a better replacement now for GIF called PNG, and we'll show you that. So that's fine. So Control 0 to get back to your default zoom. And I mean, at a small size, if this logo was only this big, you probably wouldn't really notice the jagged edges the same way, right? Or if you're on a low resolution phone, maybe it's not a big deal. But it doesn't mean we can't use something better. Something better does exist. Let's go back into our code. So there we go. So that is GIF. So let's move on to portable network graphics, PNG. Now, the PNG format, PNG is an open format. It was designed as such. It's not encumbered by royalties, so nobody paid to have this format as a capability in their bitmap editing software, like Adobe Photoshop. They didn't pay anyone royalties to be allowed to export to a PNG format. It's an open format, so it's very much a product of web technologies. It's a bitmap that is designed and was intended for transfer over a network. So it's designed to be fast, right? It's built that way. And PNGs are so good, in fact, that Microsoft adopted PNG as its default image format for Microsoft Office products. So Word, PowerPoint, and Excel, when you put an image in there, these things are built, they prefer PNG as the image format, right? The files are also XML, which is a web technology. So Microsoft Office products are actually all built, certainly a lot of them, are built purely using web technologies. So again, that kind of ubiquity of web, it's everywhere. All right, so, but there's different types of PNGs, and this is where nowadays we don't have to worry so much about the nuanced kind of differences in PNG, thanks to some newer image formats, but it's still good to know this, and it might come up in your work from time to time. So the first one we're going to embed is an 8-bit PNG. So sort of like GIF, where we're limited to 256 colors. We can have an 8-bit portable network graphics format that has that color depth limitation. It's called an 8-bit PNG. So we have one of these, and so let's fire this up. We'll put an image element in, image, src equal, and this one is chrome icon.png. So it's in the image folder, chrome-icon.png. Click that. And it's also 500 by 500. Okay. So tap that in, set the height and width, add an alt attribute as you were. If you're using XML style empty elements, have the slashy thing in there. IM, so like my meta tags are all like that, right? Where'd I go? Here we go. Oh. There we go. Save that. Now let's take a look at the page. So there it is. As well, we'll zoom it in. Cool. So there's some improvement here, I guess. It's actually attempted to do a drop shadow, right? But the problem with 8-bit GIF is that we don't have alpha transparency, right? 8-bit PNG. We just still don't have that alpha transparency. So I can't have semi-transparent black pixels that partly show the blue through and have like a nice shadow. We have to either make a decision: is the pixel opaque or is it transparent? Right? This is so this is a problem. This one didn't even try to do the drop shadow. It's like, I'm out. I'm not going to try it. Right? At least PNG, it's like, well, I'll give it a shot. Ooh, nasty, right? So you really see that, what do you call it, the diffusion or the, that kind of rasterization of the image. Also, in the same way, we get that, you can see that it's attempting to do, with a limited color table, it's attempting to do that gradient, and it does the best it can, but you get things called banding, color banding, and things like that. So it's really limited by those 8-bit colors. Again, 8-bit PNG it's not a bad format if you're not using transparency. You know, if you have solid background, 8-bit PNG is awfully lightweight file format. If you're not using a lot of subtle gradients, just solid colors, maybe something like in a logo, this is a good choice. Why do 24-bit or 36-bit color depth? Save on file size, right? It's okay. Then it's not too bad. Anyway, so yeah, there's nothing wrong with PNG. Now you can, and very few bitmap editors can actually do this. You can actually save a PNG with 8-bit with alpha transparency, right? You can actually do it. There's very few bitmap editors that can do that. Photoshop cannot do it. And if Photoshop can't do it, right, we're talking about something pretty crazy. There is one piece of software called Adobe Fireworks, which they have retired, which had the capability to save out a PNG with 8-bit with alpha transparency, partially transparent pixels. It was awesome. It was wicked. They've since shut down the whole program, letting it go. So you might still be able to get your hands on Adobe Fireworks if you can. It's a great web graphics editing tool. It's sad to see it go because we don't really have a replacement for it. Ah well. Okay, so what if we took PNG, portable network graphics, and added more color? So yes, you can have a greater, a deeper color table rather than 256 colors. You can have 24, you can have thousands or millions of colors in a PNG. Yes, you can. So you can have all the benefits of a format that includes transparency, which JPEG cannot, and lots of color depth. So let's take a look at this. COMP1002. Right? I also want you to note the difference in the file size. Okay, compare that to this is the 24-bit color depth, and I'll go to the Chrome icon. Here's the 8-bit. 19 versus 130.22. There's a cost to including additional color depth. It's there. Be aware, right? Higher quality image equals more bandwidth. There's no free lunch here. So, but you can see. Let's take a look at. Okay, so let's include this in the HTML. So same thing. So we'll go image src is equal to images / Chrome. I gotta spell it right. Chrome icon dot ping width equal. Oh, 2. You're right. Yeah, it's the second one. My bad. 5. So same native dimensions. There. So really, you can just copy the one above there and just swap out Chrome icon 2. I just did it the hard way. Decided to give myself some carpal tunnel syndrome. So if you save that, reload the page, and here's a side by each comparison. I'll give this a bit more width here. There. Right? There's no contest. Right? Look at the gradient here. Right? It's very smooth. There's no banding. Right? Because I've got now tens of thousands of colors to make that up. I have alpha transparency, so I have semi-transparent black pixels that I can use to create that shadow, drop shadow. It's a totally different thing. But the hit that I'm taking is real, right? That is like a seriously big hit to my bandwidth. So you got to balance these things out, right? It's not. Now, I don't know if you'd use a logo 500 by 500 on your page. You probably wouldn't. You'd probably have it, in, a little size. The native resolution of the image might only be 25 by 25 pixels. In that case, the difference between that file size kind of breaks down. So you might only be 1 or 2 kilobytes more than a. So in this case, you just go for it, right? Because it's a smaller. Another way to reduce the file size is just have less pixels. Period. That reduces your file size immensely. So you can have alpha transparency, certainly in a 24 or 36-bit color depth PNG, but you're going to pay for it. That's the deal. Cool. Cool. All right. So it's 9:05. I'll let you, being an early day, step out and get a coffee. When we come back, we're going to see if we can crunch a little bit of file savings out of this image with some really cool web tools. See if we can find ourselves some more bandwidth for those poor 3G people. Right? Yeah. Go get a coffee. See you in a bit.
I want the option when you click something, then something comes up. If you don't click it, then that part, entering part, would never come up like any other.
JavaScript.
Oh.
Yeah. So we're not quite there yet. So what you happen is you'd basically bind an event listener to that form element. You'd say on change. There'd be 2 values. So you'd read the value. So say it was a select button. Like say, I'm trying to think of a different pizza. So say you wanted to change between a round pizza, a deep dish, or like a thin crust. Obviously, there'd be different options for that type of pizza, right? So you'd listen for the change on the deep dish, on the select box, or the radio button, whatever you choose. And if it's if the value is deep dish, then what we do is you would either control the visibility of a certain part of the form and say, here are the options for deep dish. if it's thin crust, you'd hide this part of the form. You're a section or you use a legend and a field set for like deep dish and thin crust options. You'd hide that and show the other one. So you just toggle them out with either the visibility property with CSS. So
To do that?
you don't have you don't have to no, because we're not there yet with front end scripting and engineering. But if you really want to do it, like you're really interested, we can sit down and I can show you how to do it because it's pretty cool. But yeah, because we don't, you just have to use the CSS display property, so display block or display none, or visibility, hidden or show. So that's CSS. You change the or you could just, and then you'd have to have a little piece of JavaScript that binds an event listener to that select and changes the CSS property of those two sections for those different options. That's how you do it. I mean, that's a very simple explanation. It's a little bit more involved with the code, but actually not much. Not much. So you probably, once you saw the code, you'd be like, oh, okay, well, that totally makes sense. It's not a science of the rocket. But yeah, we don't get into like manipulating the DOM with JavaScript until like the tail end of the course. So yeah, but if you're interested in, send me a note. We can carve out some time and sit down and try to do it.
Okay.
It's up to you.
Thank you.
Yeah. Okay, so let's have a little fun here with the 32-bit ping. So there are lots of tools available. There used to be, if you have a copy of Adobe Photoshop, there's actually, if you're doing any amount of graphics editing, I'd advise you, it's probably a good idea to get it. Like if you're doing a lot of work, you can use a program like GIMP, which is excellent. If you really want to do some heavy lifting, as a student, you can get Photoshop and a whole pile of other applications for a monthly. It's kind of like a subscription now. It's called Creative Cloud, and I think it's about $19.95 a month US for students. So it's still kind of a little bit pricey, but you have to balance that out with if I'm doing a whole heap of work with bitmaps, Photoshop's a good tool to use. It's the de facto industry standard, so having access to that would make sense. For people just doing web development rather than content editing, would you need a huge, vast, powerful tool like Photoshop? I'm going to argue in today you could probably get away without it. There are some web tools, and we'll take a look at some of the cool stuff out there. One of these tools is there's lots of compressors out there. So what a compressor does is it takes a look at a file size like this large PNG, and it says, okay, can I reduce the color table? Can I move this from a 32-bit down to an 8-bit and retain the file image quality? Can we discard some data from this, either from the color or discard some fidelity? So can I make it lossy a little bit without making it noticeable to the end user and get a much smaller file size? So let's check this out. So we have already we have a situation whereby no, I don't want this one. Where's my Chrome browser? Did I kill my Chrome browser? Come on now. God, I killed Chrome. All right, so we have a situation whereby I have a ping image. I like this one. I'm not so big on this. I like this, right? But I don't like 130 kilobytes, right? That's not cool, right? I like 19 kilobytes. That's cool. So how do I do this? So let's head to there, and there are all kinds of great compressors out there. I'm going to show you one that's very popular, been around for a while. It's called Compressor. Compressor.io. Terrific tool. So this, what it does is it allows you to, so you can see that you can compare the original and the resulting image. So in this case, we took a 700 kilobyte image and used the compression algorithms here to generate one that was 250. And you can compare side by each, right? And see what the differences are awfully subtle, right? It's a really good tool. So let's try it. We'll go here and hit the big try it button, and you pull the file in. So let's pull in the file inside our image folder, the COMP1002, this one here. So open that up. It'll upload the file to the app, make a series of compression decisions, hopefully, or it'll go down in flames. Maybe not. Come on, go. All right. All right, so you can compare the two results here. There is a difference. I see the drop shadow is a little bit paler. I can see a little bit of color banding, I think, but it's not bad. All right, so let's we'll go ahead and we'll download our file. Oh, did I break it? Did yours just blow up? Oh, that's not good. It doesn't look like I can't have it. Broken. Did anyone get it working? Did this thing break on me? We'll try it again. Come on, download my file. Come on, you can do it. Waiting. Okay, here we go. So I'll show this in the folder. It worked this time. So there we go, COMP1002-compressor.png. So I'll copy this. I'll move this to my. Where are my files? Where are my documents? I'll put this in my lesson 5. Lesson files in my image. So I'll paste it here. COMP1002-compressor.ping. And you can see here, from 131 kilobytes on disk to 24. Right? That's huge. That's massive. Let's see what it looks like. Let's see, like, did I really sacrifice a lot? So let's go ahead and we'll say image src equal image / Chrome icon 2 - compressor.ping. Okay, save that. Let's take a look at our page in the browser. So now we're comparing these apples, to these apples over here. Maybe I'll zoom it down a little bit. There's 100. There's 110. Yeah, 110. So there you go. There's what we're comparing. 19 kilobytes, 130 kilobytes, 25 kilobytes. Yeah, there's a little bit of image banding, but what if I'm using this at like, this size? Maybe it won't really matter, right? How did it do? What did it do with this image? How did it achieve that massive file savings? Let's go into our file system here, and we'll take a look at the properties of this one here. So go into properties, and hopefully in the details it can tell me the color depth. Yeah, bit depth. Can you see the bit depth? It's 8-bit color instead of 24-bit, right? If I take a look at this one here, that's really huge, and I go to details. This is 32-bit color, not 24. 32-bit, right? That's the difference. So what compressor did was it was able to get, using an 8-bit PNG, it was able to achieve alpha transparency for the drop shadow without resorting to this kind of strategy here where it's sprinkled in a bunch of like whatever donut sprinkles. Okay, so that's it. That's cool. If you're using PNG, use a compressor tool. There's another great one called Tiny PNG, which is really good. Tiny, it's been around for a while. I like this one too. It's got the funny panda bear on it. So you can see this. I don't know. Compare. Let's see if we can get maybe this one will do a better job in terms of getting a file size down. Yay! The bear's happy. Save you 83%. All right. Well, let's see. Tinified. Cool. Showing our folder. Let's extract the tinified. I'll have to give this a different name. Chrome icon 2 dash tiny PNG. 22.5K. Okay. Well, let's see what it's. I'll copy this and we'll stack it up against the compressor version. Let's go into. Where's my documents here? Okay, so I'll stack it up against, so I've only got, so on disk it's 23 kilobytes. All right, let's see visually how they stack up. I'll just copy the code here. Instead of compressor, we're going to have tiny PNG. Let's see. I suspect Tiny PNG probably changed it from a 32-bit to an 8-bit with alpha transparency for the drop shadow. Semi-transparent pixels. Let's see what we did. Let's stack them up. See you later, see you later. Refresh the page. So I'm comparing, I'll wrap the page differently there. So I'm comparing this one. This is the compressor, and this is Tiny PNG. I can't. Well, there's a bit more banding here. I can see it. You probably have to look at your screen pretty hard. They both did a great job, right? And they saved a lot of file size, and I got my alpha. So that's cool. All right. So the next thing. Scalable vector graphics. So the other thing we could take a look at is why are we using bitmaps at all, right? Now, in the case of something like a photograph, yes, using a bitmap to describe a photographic image is probably the best today, the best way to go. You can use, if there are parts of the photograph, so let's imagine that we went into Photoshop and I cut out the sky and I wanted to change, put this image and have this part behind the tree transparent so I could see the blue of the page behind it. Then I couldn't use a JPEG, right? Then I'd have to use a PNG to get the transparent pixels, right? So JPEG cannot do transparency, period. It cannot do it. So if you have a photograph where you've cut pieces out and there's transparent parts of the photograph, maybe you cut out a person and you're having them standing in front of a bunch of text on the page, then you have to use a PNG or a GIF to get the transparent pixels, right? JPEG can't do transparency, but it does a really good job of generating photographs at very low file sizes. So that's your decision-making process there. But what if we're dealing with an image here whereby this is an illustration, right? It's a graphic. Why am I using a bitmap? So, because if I zoom this up, right? No matter how awesome my PNG is, if I scale this up, I'm going to lose fidelity. Right? If I need to make this bigger, I'm locked into the native 500 by 500 pixels of the bitmap. As soon as I make that 1,000 pixels or double it, I lose image clarity because it's a bitmap. The browser has to interpolate and make stuff up to make it bigger. There aren't that many pixels. There aren't 1,000 pixels. There's only 500 across, right? So what happens is I've now got something, a picture, whereby I'm tied to a physical dimension, right? That might be okay, but very often now, right, we're in a world whereby I may be viewing the same interface on my phone as my 4K TV at home, right? Geez, do I want to have to like serve up, do I have to use some sort of JavaScript, determine the document window size or the native screen resolution and serve up a different, it gets really complicated. Why can't I use something that can scale, right? Enter scalable vector graphics. Control 0 will get you back to the default zoom on your page, on your browser. Let's take a look here. You can see here, there's an href for the Google Chrome logo at the Wikipedia Commons. So you can click on this. We'll open up this in a new tab. Right? This is a vector. Right? The difference between a vector and a bitmap is a vector is not made up of dots. It's made up of text. It's a mathematical description of the drawing. So it says this is a circle. Here's the x and y. Here's the center point. I need such and such a radius. Draw that on the screen. Right? So in the middle, I need a white circle. Then I need a blue circle on top. Here, I need a gradient going from this color to this color. Right? Maybe it's a radial gradient, offset it a little bit so that kind of like, the white part's kind of up here, and so on and so forth. It can be mathematically described rather than a series of dots. If I mathematically describe this and I want to make it bigger, I can just say, make the radius for this, instead of 250 pixels, make it 5,000 pixels. And I won't lose image quality. Because it's just it's just a drawing. It's a mathematical rendering. Right? Vector. So what I can do is I can actually download this vector. Right? Download. Let's download at 512 pixels. Oh, I pulled it down as a ping. I don't want the ping. God, no. Don't want a PNG. Size of this. No, that's a ping too. I don't want the PNG. I want the vector. If I right-click on this, save image as, or open image in new tab, I'm going to get the SVG. That's a ping. Grr. How do I get the SVG?
The original file.
Original file. Here. Click on that. Ah, there we go. So click on, thank you. So if you click on under the image, there's something called original file, SVG file, nominally 512 by 512. So I want you to click on that. Now we get an SVG. See that? Okay. The file extension is scalable vector graphics. It's a different MIME type. Now we'll go to File, we'll save this, Control S, and we'll save this SVG down to our image directory for our images. So let's go into Lesson Files, Images, and I'll change this. I'll change the file name. I don't need it. It can just be Google Chrome icon.svg. Save that. Okay. Now let's go into our code. Let's put an SVG in there and compare those apples to those apples. Well, it's kind of apples to oranges. But I'll show you how awesome SVG is. Here's how we work with SVG. There's a number of ways to work with it. We can use the image element, image, source equal, image, and what do we call this crazy thing? Google, I used capital letters. That's not good practice. Google _ Chrome _ icon.svg. Set the width equal to 500 and the height equal to 500, same as ever. Alt equal there. No tricks. Just use the image element instead of pointing to a PNG or a JPEG. SVG. Set the width and height. Save that. Let's take a look at our page. Reload page. So I want you to compare these two here. Okay, compare your SVG with your bitmap. This is a totally different MIME type. It's not a series of dots. It's made up of a mathematical drawing. Watch. Zoom it up. Zoom it up. Zoom it up. Keep zooming. Look at this. There's the bitmap. There's the SVG. Look at that. Look at that. Now look at this. It's perfect. Zoom it up again. Keep zooming until you can't zoom anymore. There's the bitmap. There's the vector. You could zoom this up to the size of Georgian College. This whole plot of land we're sitting on, it would still be just as sharp. It's not made up of dots. It's a drawing, right? Huh? What are you talking about, Scott? Okay, I'll show you. Crazy guy. Let's go into our files here. I want you to open up Google Chrome icon.svg in your code editor. What? It's not binary. It's actually made up of XML. The SVG is actually kind of like an HTML file. So where we have SVG, it's actually XML, right? Which HTML is derived from, or to some degree. XHTML certainly was. So we have an SVG element, scalable vector graphics, right, as the parent tag. And then inside there, we have a number of different definitions. You can define objects like radial gradients. In this case, has a number of gradients, and then it has a number of paths, right? Vector paths. It just plots them out. X, Y, Bezier curve. It's just mathematics, right? Now you don't do this by hand. You draw the thing in a vector program like Illustrator, right? And then you output it to SVG. Well, this is really cool. So, here's the neat thing with SVG. Because the MIME type is the same as HTML, right? An image is binary. HTML is MIME type text/HTML. It's a text file. So is scalable vector graphics. So what I can actually do is I can copy all of this code. Control A for copy. I can copy all this code. I can go into my index page, right? And I can go in here in step 4B, and I can paste it in line with the HTML. I don't actually have to make another HTTP call to the server. I can embed that right in the page. HTML supports the SVG element. It's part of the HTML5 set. So I hit save. I'll zero my page out, refresh. There it is. Now, of course,
That was massive.
yeah, well, you can scale it down. So what it does is there isn't any sizing information in there. It's just the SVG element is defaulting to width 100%. So you can control that with there's attributes in the SVG element. I don't know the SVG markup that well. Where is it? In here, I think the view box. You can control that attribute. I think I forget now. I don't often edit SVG by hand. I go to Illustrator and kick it out. Yeah, but you can programmatically, and this is cool because if you're developing user interfaces or games or things like that, you can generate this stuff using JavaScript on the fly. You can animate these vectors very quickly because vectors are very lightweight. And I'm talking like, let's take a look. So this is huge, right? And the thing is with a vector, the bigger it gets, the file size remains the same. You expand a bitmap, the file size goes up exponentially. Right? So you get, with SVG, if it's appropriate, if you have a graphic, use an SVG because then at any file size, or at any physical dimension on the screen, it's the same file size. Let's take a look at our file sizes here. So our SVG, look at this. So now I've gone from 131 kilobytes to 2. We just solved our bandwidth problem, right? And the benefit is we now have a resolution-independent image. It doesn't matter what size. It's lightweight, small, and I can stretch it to whatever size I want. Vector. That doesn't mean vector is better than bitmap. It depends on what you're doing. But for some things, vector is the tool for the job, not a bitmap. For some things, a bitmap is the tool for the job, like a photograph, right? They've been doing some work to try and vectorize photographs, which is really interesting. I don't know how much progress they're making on that, but apparently they're doing some interesting things with vectorizing bitmaps, photographs in particular, and they're making some progress in terms of because a bitmap is inherently resolution dependent, so if we can make it inherently resolution independent, that would be cool. That involves a certain degree of calculus that's probably beyond my level of understanding. So, anyway, vector bitmap, that's cool. Let's go back to our code. Another image that might be appropriate for the SVG format is the Georgian logo. So I have the Georgian logo. Where is it here? Georgian logo dash SVG. Let's embed that in here. We'll take a look at that. Image src equal image slash Georgian logo dot SVG. What is the native? Hang on a second. We'll find out what the native view box is. 568 across, 194 down. So these are a set of x and y coordinates for the top left corner and the top bottom right corner. Now that's just what at the pixels at which it was drawn. But being a vector, you can obviously stretch it height and width. So I could say the width for this would be 568.2 or 568 by 194. So I can go width equal 568. 8 equal, was it 164 did I say?
194.
194? There. That's the native size at which it was at which it was drawn in Illustrator. And you can see the generator here was Adobe Illustrator and exported, right? This is an older version of, actually, I don't know, maybe it's not. Maybe it's a later version of SVG. I think they're onto SVG version 2. But you can see even SVG has a doc type, just like HTML, right? It's a controlled set. So let's save this and see what Georgian College's logo looks like on the page. Pretty cool, right? You can zoom that up, right? And the logo will not lose any kind of fidelity or sharpness. That's cool. Okay, so how can using an image editor like GIMP, how do I produce these? So let's go ahead and open up GIMP, which we've downloaded in the background now. So we'll fire up GIMP. So GIMP is primarily a raster tool. It's a bitmap tool. It's designed for manipulating bitmap images. If you want to manipulate vector-based images, that's why there's Illustrator and Photoshop. Illustrator is a vector tool. Photoshop is a bitmap tool. If you wanted the vector equivalent to GIMP, that would be Inkscape. So Inkscape is a free open source product that's fantastic. Kind of like Illustrator, you can draw in vectors and output to vectors. This will import vectors though. So let's go to File, Open in GIMP, and we'll open up the Georgian logo.svg. So open up the Georgian logo vector graphic file. So what happens is it's like, oh, this is a vector. I'm a raster or a bitmap program. So you need to tell me what's the width and height in pixels, because you can stretch it bigger and smaller and make it. It has to rasterize the image. It has to create a series of a bitmap, right? And you want to import the paths, so it can support some degree of those paths being retained. Leave it as a default and just go ahead and import the image. So now we've got this is now a raster version or a bitmap version of the Georgian logo. Okay? The gray squares indicate transparency. Okay? So now, if I want to turn this into a bitmap for web consumption, I can say, well, this could either be a GIF, it could be either a JPEG, a GIF, or a PNG. So let's go in here and just go File, Export, or Export As. And let's change the export type down here to a JPEG, just for fun. JPEG image. I have to change the file extension to the required JPG. JPG or JPEG is fine. Just make sure you change that extension up there. And I'll just put it on my desktop for fun just for now, just to see the difference here. There's the JPEG. So I'll export that. And as soon as you export that, it says, oh, this is a lossy format, right? So I can either be very aggressive and have the quality very high quality, or you can open up the advanced options here. I can crank it down to a very low quality and save on file size, right? And there's other advanced options like optimizing smoothing, which is like a Gaussian blur type because softer images are better in the JPEG, so on and so forth. Subsampling, so these are algorithms which, if you're resizing the image or it makes decisions as to, because it's lossy, what pixels do I dump and which do I retain? I don't know what DC. I have no idea what that is. So then I go ahead and hit export, and we take a look at this. Let's take a look at our desktop, and where's our JPEG? And there's the JPEG in the photo viewer. So I've outputted this to a JPEG image. Can I zoom in on this? Yeah. But if we look, what the JPEG did to that, right? It's JPEG for a graphical image isn't ideal because it discards image clarity. You get that artifact. Right? And I'll see this. It drives me crazy. I'll see this in production web applications. I'll see logos in JPEG. I'm like, is someone asleep at the switch? What a waste, right? And they'll look terrible. And I'm like, this is a reputable company. Why is someone on the front end outputting this should be a vector, or at very least a PNG. You'll see this kind of stuff all the time. JPEGs are for photographs. That's why it says joint. The P in there means photograph. Don't use, don't use JPEG for graphics or illustrations. It's just not. It's just not a smart choice. It doesn't. It's not built for that. It's not the right tool for the job. You can do it. Shouldn't. Okay, so then we can also say, okay, let's export this as, let's see about GIF. GIF image. Now I have to change the extension, of course, to the approved GIF. Put this also on the desktop. And as soon as I hit export, I'll get some, not too much in the way of, unless I have an animated GIF options. Interlacing is an interesting, where what it does is if it's a large file, it will come in passes. If you've ever seen an image come in fuzzy first, and then it comes in a little clearer, and then it comes in a little clearer, that's called interlacing. It's just a way of letting people know something's coming in, stay tuned, it will come in. And then we can go ahead and hit export. And let's take a look at the GIF on my desktop. Georgian logo. Where's the GIF? I must have stashed it somewhere else. Oh, here it is. And it's so this is fine, but I want you to look. Sure enough, it pulls up the browser, the default. It doesn't do transparency very well, right? GIF can do transparency, but in this case, or it might be transparent. Actually, it might be transparent because the page is white, but it doesn't do alpha transparency, so the edges are aliased. They're kind of nasty. Let's output this instead as a PNG. Export as file type PNG. PNG image. Change the extension to .png. No export for me. There we go. So we get a number of different. We can add lossy compression to it as well. PNG is generally considered to be a lossless format, but we can do that kind of JPEG where we kind of discard sharpness as well as the color table. That's up to you. You can save a number if there's gamma settings, which are other color and rendering settings. Interlacing, you can add interlacing like GIF. So we'll go ahead and export that and see. Here's my desktop. Where's my ping? Georgian logo.ping. So it's 11.8 kilobytes. versus the GIF, which was 3.2. But let's open this up in my browser. You won't open in the browser? You can't just drag it into the browser? Whatever. There. So you can look, you can see the PNG did a much nicer job because it has alpha transparency of doing anti-aliasing. Right? Better than the GIF did. That's cool. GIMP cannot output, to my knowledge, at least without any kind of other add-ons or extensions, to vector. So if you're going to use a vector, use a vector program like Inkscape or Illustrator. Okay, so there you go. That's how we do that. So you can, and there's no reason why you couldn't then take this. So maybe this PNG is pretty. It's not bad, right? But maybe I want to compress this. Maybe I need a bit more. I want a bit more in the way of compression. So I've got 11.8 kilobytes for the Georgian logo ping. Let's compress it. Let's go to compressor.io. That's pretty hardcore. So let's see what that looks like. So here's the original. Here's the compressed. I can't tell the difference. Download the file. I don't know, that looks pretty good. And so our file size is now, the file size is compressor. I'll put this on the desktop. So side by H, the logo is 11.8, and the compressed version, which probably brings it down to an 8-bit versus a 24 or 36-bit, I'm now at 2.87 versus 11. That's significant, right? Optimize your images. Do it. Right? It's not that hard. You throw them up on an app, you download the result. Right? It used to be a very manual process. There used to be an application called Adobe Image Ready, and they incorporated it into Photoshop, and it became something called the Save for Web dialog. And optimizing images used to be a very, very manual and painful process that required a great deal of knowledge. Now we have some fairly automated tools that make it very easy. So I am going to ask you that in your work, you make sure that if you include bitmap images, PNGs, JPEGs, GIFs, you reduce the file size. Do not give me something with a 4 megabyte JPEG on the page. Right? That's no good. Someone on a 3G connection will freak out if it even comes down to their phone. They're banned there. They'll be like, wow, what happened to my data plan? I'm getting killed here, right? Yeah, that's why. Stuff like that. Cool. All right. 1009. Okay, so that's cool. Yes, we can optimize an SVG. So, and this is cool. You can say, wow. So let's copy this. I'll copy this link. Here's there's a lot of SVG optimizers. This is one by Peter Collingridge, which is held to be one of the better ones. So let's take a look at. Where's my SVG here for Georgian? Did I put it on my desktop? I guess not. So let's go into lesson files, and inside images, we should have Georgian logo.svg at 4 kilobytes, right? I'll take a look and see what's, get the properties of this. And it's size on disk, 4K, 3.83 kilobytes, right? So let's optimize that logo. Let's choose that. With that, we'll go into here, lesson files. images, Georgian logo SVG. Open that up. And hit upload. Then he gives you a number of options for optimizing it. We can remove white space from the file. That's it, style type optimize. So you can. There's actually CSS inside SVGs, cascading style sheets, because that's a whole other discussion, but it's pretty cool. So I would leave the defaults unless you really want to get hardcore here. But you can see 3.9 to 3.3. Right? Yeah, that's cool. Let's get the properties. 3.24. It's still on disk 4K, but it is a slight. If you have a very complicated SVG, and they can get quite involved, quite complex, optimizing, you'll get better returns on your optimization. That's a fairly simple one. The team that built that did a good job of keeping it pretty clean. But you can save on file size. And you should do it. If you've got a high volume web app where there's thousands of people hitting that thing every day, you should optimize your SVGs as well. Right? Save a little bit of bandwidth. It makes that thing come down like that, really snappy. And you may be using SVGs in mobile apps, native apps for phone, for Android and iOS. Yeah, optimize them. Right? It speeds up rendering. Cool. Right on. Okay, cool. So a couple of things left to do. We'll take a break. We're going to do something called responsive images with the picture element, which is really cool. We'll show an animated GIF. We'll send you off on a little challenge with GIMP, and you'll be done your day. So take a quick break, and we'll come back to do the picture element and responsive images. Okay, so now that we're going to open up picture.html, right? Now we've got that open up here. we're going to open up picture.html for step 5a in our browser. So we'll go over here. I don't want that. I don't want that. That. See you later. So let's open up Control-O and fire up picture.html. So make sure you have the same file open up here as you do in your code editor here. Okay, so look at the path there. Make sure it's the same. Otherwise, you'll be hopelessly frustrated. So there's a bit of CSS in here. I'm not really going to talk about this too much. Just suffice to display that image elements are generally displayed inline. We need to change them for this. For what we're doing, we're going to change it to a block, which means we have a bit more control visually over how the image is rendered as a unit on the page. This margin 0 auto centers the image on the page by automatically setting the left and right margins. Top and bottom are 0, left and right are automatic, meaning it's centered. So that's cool. So inside the body, we're going to build a different element here called the picture element. Okay. So the picture element under step 5a looks like this. Strangely enough. And we'll close the picture element down here under step 5e. End of picture. So open up and close the picture element like so. Now the cool thing about the picture element is that it's if the user agent or the browser does not understand this newer HTML construct, it will just ignore it, and it will proceed through to just render a regular image element, which we'll put in here. So it fails very gracefully, but if it works, we get some really cool effects. So what I want to do here is I'd like to have a picture that is listening very much for the size of the screen. So if I'm viewing it on a screen like this, I get one version of the picture. If I'm viewing it on a tablet or if I'm in landscape view, I have a different version of the picture that's more suitable to that bigger screen. And if I'm viewing it on a desktop, I have yet a different version of the picture that's more suitable for a larger screen experience. So basically I got 3 in 1. So we'll use this picture. This is a great article by Pearl Chen at HTML5 Rocks. And so I've kind of condensed this down into a few simple steps. But so this will be the first and the last time you'll see me put a cat on the internet. Let's just put it that way. Okay, so forgive the cat, if you would. So here we go. So here it looks like. So inside the picture element, I need to create a source element. So it looks like this. source, like that. Usually we use src in the image element for source. This time I'm going to create a source attribute, and it's going to have 2 attributes attached to it. First, we're going to create a source. We're going to define what is the picture of the cat for large screen sizes. And if you look at our files here inside images, I have kitten large, kitten medium, and kitten small, right? So on a large screen, I want this cat. On a medium screen, I want this cat. And if I don't have a lot of space, I'll curl the cat up and make it small. Okay? Kind of a goofy, fun kind of, but there may be practical reasons for doing this in a user interface. So that's fine. So now we know what our crazy cats look like. Over here. So the source, first of all, the source is we create something called a media query. And this, what it does is it actually asks the device, what width do I have to work with in CSS pixels? So I use a bracket and I say min-width, and I say 650 px, pixels. So what I'm saying is, if the screen is a minimum of 650 pixels or greater, we will use the following. We will set the source, src, set. So source set equal to, and then I include the path to the kitten. So this would be image slash, what did I call it? Kitten dash large dot ping. PNG. And source is an empty element, so we just simply close it off like so. So this says, look, if the screen is 650 pixels or bigger, let's set the source of this picture to this ping. Stretch the cat out. All right, what about for medium sizes? Excuse me. Okay, so source, same thing. We'll do a media query this time. Media equal to, and we'll say min dash width. So if it's at least 465 pixels, then we'll set the source, or source set, equal to image img slash kitten dash medium dot png. Close the quotes and the source element. Okay, so if the screen is if it's 465 or bigger, we'll get the medium kitten. If it's 650 or bigger, we'll get the large kitten. And now we need the fallback for the small kitten. So we'll get a basic, and this one, we don't need to use the source. What we can do is we can actually just create an image element, image, and the source by default is equal to image slash kitten dash small dot png. And then I also need the alt equal to kitten. There.
Do you need an alt for the other ones?
No. No. So, yeah, so to put in large kitten in here wouldn't work. So how the mechanics of this is, if this is true, then we set the source to this, right? So I'm dynamically changing this source attribute here in the image.
So kitten will show for all.
That, yeah, we're going to use that to render any of those three. But so the alt should just describe in general what the picture is. The other thing too is if the user agent doesn't understand this picture element, because it's fairly new, it's just like, I don't get that, don't understand the source tag, don't get that. Oh, I get that, I'll render that, and then it gives you the small kitten, and you're good. So it fails gracefully, right? So we'll save that. And let's go to our browser, reload the page, and you should have the kitten stretching out. Big screen, right? Let's shrink it down. Medium kitten, small kitten. Right? Responsive image, right? Why not give people a better experience if they have, or not a better, but an appropriate experience? You can right-click on the screen if you're in Chrome. You can do this with any browser you can inspect, and you can bring up in Chrome, you can click up the little device toolbar here. So you right-click, there's a little mobile thing, you can click that, and you can do responsive. I'm not sure if this will work. No, it won't work on, no, it won't work. I know why. I don't want to get into that just yet. Yeah. No, I digress. Let's not do that. There's some more code I'd have to put in there to get that to work. So there you go. So, but that will work on with some other. So what I can do is I can copy the above picture code and I can paste it back into index. So I can go into from line 16 where I put picture, and I can copy all the way till I close the picture element there. We're going to take this out of picture and put it into the index.html that I was working on before. Over here. And I'll paste the picture code right here. Make sure you format that code. Right? It's a child element of the section, so it should be tabbed in one tab stop. And the source attributes, or the source elements, are children of the picture element, so they should be tabbed in one tab stop. So be proud of your code formatting. Right? Give me good, well-formatted code. So there's picture, step 5. And our last one, before I set you loose on the lab, I know it's been a long journey here, is the animated frame-by-frame GIF image. So here, under animated, so step 7a, we'll create one more image element. Image source is equal to img, and in here we have the arrow-spinner.gif. GIF. Alt equal spinner. So you must have the alt as you work. Save that. And if I go back to my index page, here's my cat. I go down here, I can see. So those are those things, you see the maybe the little kind of things that spin around as things are happening, things like that. You can use a GIF. So a GIF is a bitmap, but it's a series of bitmaps, frame by frame, right? So they're actually quite large file sizes to do animation. I might argue, though, the problem with GIF, if you can see this one, if I wanted a spinning arrow on a blue background, I can't get a nice smooth. Edge on with transparency because GIF doesn't support alpha transparency. So I'm going to have like a kind of a crusty looking animated GIF if I need it to be transparent. If it's not transparent, I can have it nice and smooth, but then I have to make a decision as to the background color and make sure it matches the page. So I'm going to argue that if you need to make it some sort of element on your UI, like something's loading or something's spinning around, I would say use an SVG and animate it with CSS or JavaScript. Then you can make it bigger or smaller. It looks really nice. You don't get you're not stuck to the limitations of GIF, which is a larger file size, because every time you add an animated state, you add another copy of the bitmap onto the GIF. So even a very small animated GIF can be a very large file size. If you're using an SVG, just include instructions to spin it around. They're very small. So I don't know. I don't see a massive future for animated GIFs, but all things have their use, right? You may find a use for it. It can be done. So there you go. So your challenge for the day, Lab 5. Let's head back here. I guess I need to go to, since I logged out. Yeah. Web and Internet Fundamentals, Learning Modules, Module 5, Images, Lab 5. Okay, cool. So there's some files for you to download. I'll walk you through those. Here's the PDF. So what I want you to do is there's 3 different things I want you to do. I'm giving you a bitmap. This is in a PSD, Photoshop document format. I want you to use GIMP to open up this picture of the camera. Right? Open it up. I want you to resize it to a width of 250 pixels using the image scale image. I'll show you that in a sec. And then I want you to output file export to a JPEG and put it in the provided HTML page. Then I want you to use this, go back to GIMP and output it as a PNG. And then output that in the HTML document and then finally as a GIF. Okay, so I want you to open up GIMP. Can't even see it. GIMP. There we go. Open up GIMP. And I'll show you the downloads. So what have I got? What are the goodies I'm giving you for the lab? Lab5.zip. Save these down. It's not very big. Extract the Lab 5. Okay. You can ignore the OS 10 stuff. Don't get into that. So inside Lab 5, you'll have a PSD. You'll have an images page, an images folder, and a CSS folder. You don't need to worry about the CSS. So you'll open up images.html in your code editor. Where's my Lab 5? There it is. Images, so open up images in your code editor. And you'll see step 1 for JPEG, step 2 for ping with transparency, and step 4 GIF with transparency. Okay? So those are your that's where I want you to create the image elements in there. And then in GIMP, I want you to open up File Open, Desktop, Lab 5. Open up the bitmap, which is a PSD, Photoshop document. Yes, GIMP can handle Photoshop documents. They're pretty open. So the first thing I want you to do is take this. You can see it's a picture of a camera with a transparent background. First, I want you to resize this physically to 250 pixels. Right now, it's like 3,000 pixels wide. So we go to Image, Scale Image. And then you set the width to 250. If this little thing is locked, which it should be by default, you hit Tab. This height will change proportionately, so you don't squish it or stretch it. And then you hit Scale. Right? You can change the zoom, maybe a little tiny. You can change the zoom to 100%. Now you have a 250 pixel wide bitmap. Now I want you to go ahead and File, Export As, and give me a JPEG, a PNG, and a GIF with transparent background. Of course, the JPEG can't do it. Okay? Cool. Then submit your code to the Lab 5 here when you're done. If you'd like to, you could use compressor.io or tinypng or some other if you want to see if you can crunch down the images to an even smaller file size than GIMP can produce. See how small you can get those file sizes and still get it to look good. Right? Right on. Cool. So next week is study break. Do not come here. You can. I won't be here. Okay? I'll be very quiet. So enjoy your break. Well deserved. You guys have you've got a lot on your plate. Take some time. I mean, get caught up on stuff if things are you're behind, but take some time to relax as well. The brain's like a muscle. Needs to rest to get stronger. Make sure that there's a couple of articles here on image optimization. So some work that's going on with the browser vendors on vector graphics. Built-in browser support for responsiveness. Here's a new image format called WebP, which is kind of cool. Make sure you finish the quiz and do the required reading, Chapter 5. It's not long, but it's very interesting. It's very cool. And the week after study break, come prepared. We will have a test 1. Okay, will be the week after study break. I'll send out an email reminder. Please come to class. We'll write the test in class on Blackboard. Okay.
Do you have a review that you're going to post? Or?
The review are the quizzes.
Okay.
So if you follow through the quizzes, you're very well prepared for the test.
Okay.
Yeah.
I've done any of them.
All right. Here's your chance. They're not huge, right? Yeah. So you haven't dusted off the book? Go for it. Cool. Question? Somebody got a hand up? No? Can you do? Yeah, you can do this as many times as you want. I'll take the last one as your official.
So you said you're going to be here next week in your office.
Yep. Yeah, send me a note. We'll make an appointment because I got.
What are we doing about the thing? What cost or what?
Send me a note.
What? Yeah, the cost as well.
There's a lot of people who are supposed to know. It's just a process. Verify your email. Verify your email. Seems to be pretty straightforward.
Yeah. I'm not very
Seems to be adding the Azure as a
There's no
subscription to your Microsoft. Where we have it.
Yeah, because that's where I've been trying to see. How do I verify?
Yeah,
Yeah.
So we'll figure it out. Okay. And we'll also we'll get you. We also have something called renewals. We need to account there. So if all things really come on the way, just can't enter a subscription. You use renewals. It's the same as those.
No problem.
Yeah. Yeah, so it's
I'm sorry. Show up halfway through the class. Yeah, I don't understand.
not on your computer. Search the web, right? And you log in.
I'm okay with that. Just don't know over the class. Says that. He's talking to you in the process 12. I don't understand. They're not even there. His office hours say 1 to 2. Yeah. No, this shit even makes sense. Totally. Where's his office? Okay. Let's go there. I don't even have my agreement.
Looks like you're ready. All the